Hey guys, welcome back to another Hartman Controls Protector.net tutorial. Today we'll be demonstrating how to connect and configure an elevator panel in Protector.net. The elevator panel can provide access control to individual floors in an elevator. We can accomplish this by intercepting the elevator buttons for floor selection and placing a reader inside the elevator cab. Our elevator panel hardware consists of two main pieces: the elevator master panel, which connects to the readers and makes decisions, and the I/O board. These slave boards connect to the elevator panel via RS-485. Each I/O board has 8 dry contact inputs and 8 solid-state outputs. Up to 8 can be connected to a single master controller, giving us up to 64 elevator floors per master controller and up to 4 independent cabs. Our system supports button sensing and non-button sensing elevator technology. Non-button sensing, seen in the display diagram, is when the floor buttons in the cab go through our relays before going to the elevator system. When a user presents a credential to the cab, a master controller will activate any relays that correspond to the floors that cardholder should have access to. The cardholder now pushes a button for a floor, which will go through our relay and to the elevator system. The main disadvantage of non-button sensing is that we can't see which floor was selected. Button sensing, seen in this display diagram, is when the floor buttons go straight to our inputs. This is only possible if the elevator buttons are dry contact. Our outputs connect to the elevator system and is looking for a pulse from our controller. When a user presents a card, we decide which floor buttons are allowed to work. When the user pushes a button, we will send a pulse with our relay based on the floor selected. The big advantage here is that we can log the button press in the software and see exactly which floor the user selected. Now that we have an idea of how it all works, let's connect an elevator controller to our software. First, I'll start by powering it up via PoE. And just like any of our other controllers, we can start by holding the enter button on the master controller for 3 seconds, followed by the escape key. The panel has already gotten an IP address through DHCP, so all I'll need to do here is give it the server IP address. Click escape once you've entered the entire IP address, and confirm the change by hitting enter. Log into the software if you haven't already. And in a few moments, we get an unknown notification from panel. I'll click right on this notification, and now we're on the Add Panel page. For the panel model, I'll be sure to select PoE ELV64. Fill out the name, site, and fill in how many I/O expander boards are attached to the elevator controller. Make sure you fill out the TCP connection section if you gave the elevator a static IP address. Click Save and Continue Configuration. Disable the temper sensor if desired. Next, we want to attach an elevator to this elevator controller. We'll go back to the home page, scroll down to the hardware section, and select elevators. We'll click the Add button here. We'll give a descriptive name to our elevator, usually based on the floors or what cab number or location within the building. Select a panel from the drop-down list. Select if you'll be using button sensing or non-button sensing. In this case, we're going to use non-button sensing. Finally, the last part of the page is sort of a wizard to build your floors. Select a starting floor number. If there's a basement, start with floor 0. We support negative floor numbers as well. Select how many floors we're going to be controlling in this cab. This is used to automatically assign floors to inputs and outputs. In this example, I'm going to have 4 floors starting at floor 1. Click Save, and continue configuration. On the General tab, after we add the elevator, we have 2 new options: button delay and relay pulse time. On the General tab, after we add the elevator, we have 2 new options: button delay and relay pulse time. Button delay defines how long after a card presentation that the controller will accept a button press is valid. This applies to button sensing only. Relay pulse time defines how long we activate the relays after a valid credential or button press. I'll increase this to 2 seconds. On the Floors tab, we can finally assign and configure individual floor schedules. We can rename any of the floors as needed. The time zone column will let us select a floor time zone. We create a few by default for you. You can create more if needed. For now, I'll make sure every floor is always card access except the main floor, which I'll keep unlocked at all times. We can also assign Floor Holiday Group, which will allow us to use an alternate floor schedule on a holiday if desired. You can save individual changes to a floor with this button here, or save all changes with the button above the column here. The next step is to assign a reader to the cab. This is optional since you can just place an elevator on a schedule if card access isn't required. In our case, we'll name our reader Cab 1. We'll select a reader port and click Save. Next, we'll take a look at the floor map so we can see which floors correspond to which inputs and outputs. Head to the Edit Panel screen for our elevator panel. This last tab here, the Floor I/O tab, will display sort of a map in between what the floors are and what the corresponding outputs and inputs are. This is useful for wiring purposes. Lastly, I'll need to make sure I have an access privilege group that includes those new floors. Now that I have my floors in an access privilege group, I'll do an update to the controllers. We'll present a credential to the elevator reader. As you can see, it fired the corresponding relays representing the floors that we had access to. That concludes this tutorial. For more information about elevator controllers, please see the applicable chapter in the software guide.